Dear students, welcome back to my channel, Mahendra Academician Expert Yami. Today's topic is the importance of material science. The today's presentation content is objective. What are objectives of importance of material science? Material. What is material science? Why materials? Application of material science. Property of material. Processing of material. Material characterization. So what are the objectives? What are the importance of material? We all are surrounded by the materials everywhere. Take the mobile phone, take the cloth, take the building, take the road, take the automobiles, aerospace, trains, bullet trains, ships, everything. We are surrounded by the material. Then importance of material science in the present developing era is very important to spread awareness regarding the innovation and contribution of material world in the revolutionized science and technology, to strengthen the platform for material knowledge and research. These are objectives. Why materials is very important, why we need advanced materials in power sector, in supercritical power plant. We need high temperature resistant material which can sustain temperature up to 1500 degrees Celsius for creating the light. Edison uses tungsten coil made of tungsten material which is having high melting points. And everywhere for particular purpose we need advanced materials for lightweight, for miniaturization in today's globalization, everywhere, energy sector, in communication sector, in service sector, everywhere we need good material having good property. So what is material? How we define the material and what is engineering materials? Substance of which something is composed of. Engineering material used to produce technical product. Material science, material science is a scientific discipline which is primarily concerned with the search for basic knowledge about the internal structure, property, and processing of material. So, material property is dependent on the microstructure and its constituent. What are the elements present in the material composition and the morphology? How the composition, how the structure microstructure of the substance. These things decided the mechanical materials property for which particular application it is used. So in history of material science, civilization is defined by the materials. In olden days, stone age comes into the picture. Then after stone, then bronze age, iron age, polymer age, concrete steel age, and then silicon age. Now today is information age. So from BC to AD, these types of material came into the picture. From the material civilization is defined. Material is very important. Everywhere we use the material. So if we go to classification of materials, then material can be classified on the main basis of this one is metal or non-metal. Metals means it is having electron, proton, and non-metals means there are no electron is present. So if we are going to define the metals, then main basis of classification is ferrous metal and non-ferrous metal. Ferrous metal means iron is present. Non-ferrous means iron is not present. If we are going to classify ferrous, then ferrous is two types, steel and cast iron. And non-metal, if we are going to, then polymer and ceramics. These are the two. Each class has its own property and unlimited application. Then next, we can design the material. Now this era is going on. We can design the material for which specific property we need. If we need high strength and high toughness, particular application, then if we need high wear resistance, if we need the material which is having high temperature stability, hardness, then we have to make the composite. Composite means we can combine the two material for getting the two property. Suppose one is the metal and another one is the reinforcement. Metal is not that much hard, then we put the reinforcement of ceramic particle which is having high hardness. Then we get both the property, ductility as well as strength, high strength as well as high ductility. So these types of material is today days is high demanding and lots of research is going on these types of material in research and laboratory. If we may use metal for making the composite, then metal matrix composite come into the picture. If ceramic we use, then ceramic matrix composite. Polymer if we use, then polymer matrix composite. So in today's lots of research is going on these types of material: metal, ceramic, and composite. These are the three pictures where material plays a very important role. Next is the application of material science in aerospace, automotive, electronics, and medicine. Aerospace, if we want lightweight material having high strength, then aluminum. Aluminum is having the lightweight, but its strength is not that much the required in that application. Then we use for titanium and nickel based parallel. Titanium is having low weight and also high um, strength. So these are the things in going in material science field. Automotive, in automobiles lots of material is required for pistons. Suppose you are making pistons, aluminum material, steel material, and lots of research is going on every time. The material which is having the the lightweight so that our engine efficiency will be high and having good property, so that we can run at a high speed and fuel consumption will be less. Component should be very having good efficiency and high quality. Lots of research is going on in the field. So next one is the electronics industry. In electronics, what is happening? Silicon is the material which is used for making semiconductor. The microchips is manufactured by using silicon material. Silicon is very important in the electronic field. Next one is the medicine field. In medicine, what happening? Lots of research is going on for developing the medicine which is used for disease, removing the disease. So lots of research in going on for in biomedical engineering for creating the human body part, bones, so that if a human gets body parts gets failed, then we can provide that material. And in medicine too lots of research is going on which material is used for nanoparticles be used for detecting the cancers, destroying the cancers. Application in aerospace industry, if we are researching which material is used in aerospace industry, aluminum 70%, composite 11%, titanium 7%, steel 11%, other 1%. These are some research on the materials which we normally used in aerospace industry. Biomaterial, as I have already talked about, finger joint, heart valve. Finger joint is made of silicon rubber. Heart valve is normally made of polyester stainless steel. Hip joint is made of titanium. Artificial heart is polyurethane metals. So these are the biomaterials. Next, lots of teeth and different types of material is used for making the teeth. Next is the comparison of property. Which material is having which property? If we are talking about polymer, this polymer having less density and high strength. Metal density is high and strength is also high. Ceramic density varies, strength very high, in compression is also very high. Composite density moderate low and strength very high in compression and tension. So what are the property of material which require? So if we are talking about the material property, then we will discuss some property which is very important. Property of materials, main property is the elasticity, plasticity, ductility, brittleness, malleability, toughness, hardness, strength. So what is the strength? This property enables material to resist fracture under load. So high strength is the requirement of every material, and material should be lightweight so that efficiency will be high. Machinability is the another aspect. For creating any product, we have to do the operation by using machine for getting the desired shape and size. So if machinability is poor, then we have to face lots of problem during machining. So machinability should be very good so that for doing the machining operation, force requirement should be less. The machine tool not wear out and tool life will be more, and other lots of the thing is there. And so materials work hardening does not took place. If work hardening took place, then for further machining is not possible. High hardness, if material is hard, then it can sustain the different component and its life will be more. Corrosion resistance, if we are using the product for in some acidic environment, alkaline or environment, suppose in petrochemical industries and in saline water, in submarines, in seas, lots of application in oil industries, petrochemical industries, then corrosions will happen. Then material proper should be such that it's resist to the corrosion. Next is the thermal resistance. If temperature is high, then material should not get melt, it should sustain their structure. So melting point should be high. Next is the piston. Piston is very important part. That piston is used for generating the power from piston. What do the piston? On piston, we apply the forces, then this energy gets converted into the mechanical energy. Chemical, petrol, we use the fuel, petrol, diesel, and this fuel produces the energy, and that energy uh, put the force on the piston, then piston gives the mechanical energy. These types of things happen in all the engines. If we are talking about engine, then engine what happen? We produce mechanical energy from the chemical energy of the fuel. We use the fuel and fuel get burns and combustion took place. After combustion we get the energy, and then this energy is used for running the piston. The piston is very important thing. Then how we make the piston? Piston is made of aluminum, cast iron, and steel. Aluminum and cast iron are preferred mainly because lightweight, corrosion resistant, easily machinable, and cheap. This is the figure of piston and connecting rod. In engine, piston is everywhere. Processing of the material. If we are getting raw material from the earth, lots of mine is there. Aluminum comes from the earth in the form of bauxite. Steel comes in the form from the raw material we get from the mines. It- Then by using different processing, first extraction, then processing it, cupola furnace, muffle furnace, and other furnace we use pig iron and get converted into the different types of pig iron is the getting from the earth. Extraction, shaping, machining, heat treatment, and surface treatment. After the getting the material, we have to shape it in the proper shape. Suppose we want to make crane hook, sharpen cutting tool, flywheel, gear, pulley. Then we have to do the shaping, lots of operation, manufacturing. We say that manufacturing, casting process, machining process, building process, farming process. That after this we get the desired shape and size. Next one is the heat treatment. What are the heat treatment? Heat treatment is done on the material for getting the property which we require. Suppose we want ductility. Material during machining get over hardened. Then we perform the annealing process. And suppose we want the surface should be very hard. Then we use quenching operation. So then these types of thing happen. Surface treatment. Suppose we want the substrate material should have different property and surface should be different property. Suppose we want to create a tool. The tool's bulk substrate should be having high toughness and high hardness, and its surface. So then we make the material tool of tungsten carbide, and it we coated the surface by using titanium nitride, titanium aluminum nitride, aluminum dioxide. So it having high hardness, high oxidation resistance, and good anti-friction property. Then surface treatment type of the thing will happen. The lots of processes there, coating, cladding. So by using doing this operation, we do the surface. We make the surface having different property. These are the things which happen in coal mines. We use coal for getting the energy in power plant. Next one is the next figure shows the casting process, and after that drilling tool is for used for machining process, and here lots of tool which is used for creating different shape. Here we use forging operation. Here we done heat treatment process. So these are the things which happen to the materials study. What are the subfield of material science? Nanotechnology, crystallography, material characterization, metallurgy, electronic and magnetic materials, surface science, tribology, ceramic and reinforcement. The material science is a very wide subject. Lots of things is there. Material structure. The for studying the material structure, we use crystallography. material characterization, metallurgy, how we can create the materials, surface science, ceramics, and reinforcement. Nanotechnology, control of matter at the nanoscale. A structure having at least one dimension between 1 and 100 nanometer is known as nanostructure. Interesting feature of nanotechnology, increased miniaturization with enhanced performance, enhanced electrical and optical property, material with greater strength. Small thing make a big difference. Feynman is the scientist name who developed. Okay, there is a bottom in there is a sufficient scope in the bottom. So if we create the structure of material at nano level, then different property come into the picture. Crystallography, atomic structure, crystalline, non-crystalline. Then I am going to talk about what is the crystalline material and what is the non-crystalline material. Crystalline solid, in crystalline solid regular arrangement of crystal happen, and in amorphous solid irregular arrangement of crystal happen. Crystal lattice, it is a regular 3D arrangement of constituent particle in space. Each point in a lattice is called lattice point. Then unit cell. What is the unit cell? Unit cell, it is the smallest 3D portion of a complete space lattice which when repeated over and again in different directions produce the complete space lattice. Unit cell is the smallest 3D portion of a complete space. The dimensions along the three edges A, B, C, which may or may not be mutually perpendicular to each other. So these are the things about the unit cell. Grain size is very important. Grains and grain boundary as you see in the figure. The smaller the grain, the stronger is the material. The grain should be smaller. This is the microstructure. Ferrite crystal structure, pearlite microstructure, and austenite crystal structure. Why material fails? Lots of defect in the material. Then upon applying the forces, crack initiation start. After crack initiation, crack propagate and fracture will took place. Casting defect, crack initiated at voids, crack propagation along grain boundary, and then fracture took place. Next is the material characterization. Microscopy is used for seeing the grain growth pattern. Next, next thing is the tensile test on universal testing machine for getting the tensile strength, compressive strength, shear strength. Next is the hardness testing, resistance to abrasion, which is done on the Rockwell hardness test, Beaker hardness test, Binal hardness test. X-ray analysis is used for studying the crystal structure. Braxla is there, 2D sin theta is equal to n lambda. So then non-destructive testing, surface and subsurface defect, white layer formation, work hardening. These are the things which we study in the non-destructive testing. Here is the picture which shown the tensometer. Tensometer is used for tensile testing, which is mechanical based instrument. Universal testing machine is a hydraulic operated machine. Metal and alloy polymer composite we can test by using universal testing machine. Compression test. Bending test, shear test can be performed. That's all about the materials. I'm going to talk about some more things. What are the pure material and what are the alloy, super alloy, then composite, and what are the difference between alloy and composite? So first I am going to tell what are the alloying element in the steel. If we put the carbon in the steel, carbon percentage is more. You know, then tensile strength improve, hardness improve, resistance to abrasion improve, reduces ductility, toughness and machinability. If chromium percentage is more in the steel, improve tensile strength, hardness, hardenability, toughness, resistance to corrosion and scaling at high temperature. So these are the different elements which put different effect. Cobalt, if we use cobalt, increase strength and hardness, red hardness of high speed steel. Columbium, stabilize stainless steel. Copper, improve corrosion resistance. Manganese, react with sulfur to improve forgeability and reduce sulfur embrittlement. Also improve strength, hardness, hardenability, scaling and distortion effect. Molybdenum increases strength, hardness, hardenability, toughness as well as creep resistance. Also improve machinability, resistance to corrosion and red hardness. Nickel increases strength and hardness without sacrificing ductility and toughness. Nickel is used for increasing strength and hardness. Phosphorus increases strength, hardness, and machinability. Silicon increases tensile and inert strength, hardness, forgeability. Sulfur improve machinability in free cutting steel, but without sufficient manganese, it produces brittleness at red heat. Tungsten increases strength, wear resistance, hardness, and toughness. Vanadium increases strength, hardness, wear resistance, and resistance to shock impact. The other most important thing during in the metals is type of crystal. Simple cubic unit cell, body centered unit cell, FCC, face centered cubic cell, hexagonal closed pack structure. These are the things. Then next thing is the defect, point defect, line defect, surface defect, volume defect. So that's all about the basic fundamental thing about the material science. I am going to stop today video.